Summer 1940. Somewhere over the English Channel. A Royal Air Force pilot spots a Messerschmitt Bf-109. He's behind it. Perfect position. He pushes his stick forward to dive after the German fighter. And then his Rolls-Royce Merlin engine coughs, sputters, dies. For 1.5 seconds, an eternity in a dogfight, his Spitfire becomes a glider. No power, no control. The German pulls away, escapes, again. This wasn't a mechanical failure. This wasn't pilot error. This was a design flaw. A fatal design flaw that was killing British pilots every single day.
The RAF knew about it. Rolls-Royce knew about it. The Air Ministry knew about it.
Nobody could fix it. Until one woman, a motorcycle racer who'd been banned from entering the engineering building because she was female, solved it with a brass washer that cost less than a shilling. Her name was Beatrice Shilling, and this is her story. To understand what Beatrice Shilling did, you first need to understand the problem she solved. The Supermarine Spitfire and the Hawker Hurricane were the two fighters that defended Britain in 1940. Both were extraordinary aircraft. Both were powered by the same engine, the Rolls-Royce Merlin. The Merlin was a masterpiece. A V12, liquid-cooled, supercharged engine producing over 1,300 horsepower. It was powerful. It was reliable. It was beautiful. But it had one critical weakness. The Merlin used something called an SU carburetor. SU stood for Skinner's Union, the company that made it. It was a float-type carburetor, similar to what you might find in a lawnmower or an older car. Here's how it worked. Fuel flowed into a small chamber called the float chamber. Inside was a floating device that controlled a needle valve. When the fuel level dropped, the float dropped, the valve opened, and more fuel came in. Simple, elegant, effective. In straight and level flight. But in a dogfight, nothing is straight and level. When a pilot pushed his stick forward to dive, when he went into what engineers call negative G, something terrible happened. The fuel in the float chamber didn't stay at the bottom. It got pushed to the top, away from the jets that fed the engine. The engine starved of fuel for 1.5 seconds. But that wasn't the worst part. If the negative G continued, the fuel collected at the top of the chamber and pushed the float down to the floor. This opened the needle valve completely, and suddenly the carburetor flooded with fuel. Too much fuel, the supercharger drowned in an over-rich mixture. And the engine didn't just hesitate, it died. This was called a rich mixture cutout, and in combat, it was a death sentence. Now here's what made this particularly devastating. The German Messerschmitt Bf-109 didn't have this problem. The Bf-109 was powered by a Daimler-Benz DB601 engine. And the DB601 didn't use a carburetor. It used direct fuel injection. With fuel injection, there was no float chamber. No float, no needle valve. Fuel was injected directly into the cylinders at precise moments, regardless of the aircraft's attitude, which meant a German pilot could push his nose down, go inverted, do whatever maneuver he wanted, and his engine kept running perfectly. British pilots couldn't follow. Imagine this scenario. A Spitfire pilot is chasing a Bf-109. He's gaining. He's almost in range. The German pilot sees him in his mirror, pushes his stick forward, and dives. The British pilot follows. His engine cuts out. For 1.5 seconds, he's powerless. The German pulls away. Or worse, the German loops back. The Spitfire pilot is still recovering. The Bf-109 comes around behind him. Now the hunter has become the hunted. This happened constantly during the Battle of France in May and June of 1940. And it was happening during the Battle of Britain. British pilots knew about it. They complained about it. They begged for a solution. The standard workaround was called a half roll. Instead of pushing the nose down directly, pilots would roll the aircraft inverted first, then pull back on the stick. This kept the fuel at the bottom of the float chamber because the aircraft was upside down. But a half roll takes time, precious seconds, and it telegraphs your intentions to the enemy. The RAF needed a real solution, and they needed it fast. Rolls-Royce was working on a new carburettor design, but developing a new carburettor, testing it, tooling up factories to produce it, retrofitting thousands of aircraft, that would take years. Britain didn't have years. Britain had weeks. And that's when Beatrice Shilling entered the picture. Beatrice Shilling was born on March 8, 1909, in Waterlooville, Hampshire. Her father was a butcher, her mother was a homemaker. Nothing about her background suggested she would become one of the most important engineers of the Second World War. But Beatrice, who went by Tilly to everyone who knew her, was different from the start. At 14 years old, she bought a motorcycle with her own money. Not to ride, to take apart. She spent hours in the family shed, disassembling that motorcycle engine, studying every component, figuring out how it all worked together. Then she reassembled it. Then she rode it. Then she made it faster. Tilly's mother, Annie, recognized something in her daughter, and she did something remarkable for 1923. She found an organization called the Women's Engineering Society. The Women's Engineering Society had been founded in 1919, right after the First World War. During that war, women had worked in munitions factories, in aircraft plants, in every industry that needed skilled hands. When the men came back, most women were pushed out. But some refused to leave, and they organized. Annie Schilling got her daughter connected with the Women's Engineering Society, and through them, Tilly secured an apprenticeship at an electrical firm. In 1929, at age 20, Tilly enrolled at the University of Manchester to study electrical engineering. She was one of 2 women in her entire class. Think about that for a moment. 1929. The world was about to plunge into the Great Depression. Women couldn't vote in many countries. They were expected to be wives and mothers. And Beatrice Shilling was studying engineering at one of England's most prestigious universities. She graduated in 1932 with her degree in electrical engineering. But she wasn't done. The next year, she earned a master's degree in mechanical engineering. While she was studying, Tilly discovered her other passion: speed. Brooklands. The name itself was legendary. The world's first purpose-built motor racing circuit, located in Surrey, England. Opened in 1907, a massive concrete oval with steeply banked curves. Brooklands was where speed records were set, where legends were made, where men, mostly men, pushed machines and themselves to the absolute limit. And in the 1930s, Beatrice Shilling was there. She wasn't there to watch, she was there to race. Tilly raced motorcycles at Brooklands throughout the 30s, not on some factory-supported bike with a team of mechanics, on her own Norton M30 that she maintained and modified herself. She understood that bike intimately. Every gear, every bearing, every adjustment that could squeeze out another mile per hour. In 1934, Beatrice Shilling did something that only 2 other women had ever done. She lapped Brooklands at over 100 miles per hour, on a 500 cubic centimetres Norton, that she had supercharged. Herself. 106 miles per hour, to be exact. This earned her the British Motorcycle Racing Club Gold Star, one of the most prestigious awards in British motorsport. Tilly Shilling was 25 years old, a woman with 2 engineering degrees, a motorcycle racer who could outperform most men. And she was about to enter the male-dominated world of military aviation. In 1936, Schilling applied for a position at the Royal Aircraft Establishment at Farnborough. The RAE was the primary research facility for British military aviation. The most advanced aeronautical research in the country happened there. The Air Ministry was actually somewhat open to hiring women. They'd learned during the First World War that capable engineers were capable engineers, regardless of gender. So, when Schilling applied, they offered her a job. But there was a catch. The chief engineer at RAE wouldn't allow women in his building. Literally. Women were banned from entering the engineering building. So Schilling was given a position in the Technical Publications Department, writing handbooks about aircraft engines. Not designing them, not testing them, writing about them. For 8 months, Beatrice Shilling, master's degree in mechanical engineering, Gold Star motorcycle racer, sat at a desk and wrote documentation. Most people would have quit. Most people would have accepted that this was as far as a woman could go. Tilly Shilling was not most people. After 8 months, she managed to get transferred to the engine department. She was assigned to research and development on carburetors. Carburetors. The universe has a strange sense of humour. Schilling threw herself into the work. She wasn't just competent, she was exceptional. She could do practical tasks that many theoretical engineers couldn't. She could braze copper joints herself. She could machine parts in the workshop. She understood engines not just as theoretical systems, but as physical objects that she could touch and modify and improve. The workers in the factory started to respect her. The management started to notice her. On November 1st, 1939, 2 months after Britain declared war on Germany, Beatrice Shilling was promoted. She was now the head of carburetor research and development at the Royal Aircraft Establishment. And almost immediately, the complaints started arriving from the front lines. The reports from pilots were consistent, and they were alarming. Spitfires and Hurricanes were experiencing engine cutouts during combat. The negative G problem wasn't just theoretical anymore. It was killing people. Schilling understood the problem immediately. Float carburetor, negative G, fuel starvation followed by flooding, engine cutout. She also understood why Rolls-Royce's solution was taking so long. Designing a new pressure carburetor was an enormous engineering challenge. It required new manufacturing processes, new testing protocols, new quality control standards. Even in wartime, these things took time. But Tilly Shilling wasn't interested in waiting for the perfect solution. She was interested in a solution that worked, right now. The principle was simple. If the problem was too much fuel flooding the carburetor during negative G, then the solution was to limit the fuel flow. Restrict it to just enough for maximum power, but no more. Schilling designed a brass disc, shaped like a small thimble, with a precisely calculated hole in the centre. The dimensions had to be exact. Too small, and the engine wouldn't get enough fuel for maximum power. Too large, and it wouldn't prevent flooding. She made 2 versions, one for engines running at 12 pounds per square inch manifold pressure, one for supercharged engines running at 15 psi. The device was elegant in its simplicity. It could be welded directly into the fuel line before the carburetor. No disassembly of the engine required. No taking the aircraft out of service. A mechanic could install it in minutes. But when Schilling presented her solution to the RAE hierarchy, they were sceptical. The official position was that Rolls-Royce was developing a proper solution. A new carburetor, engineered correctly, tested thoroughly. Schilling's brass disc was a hack, a workaround, a band-aid. It wasn't elegant, it wasn't sophisticated, It wasn't the kind of solution that impressed engineers who had spent years designing complex systems. But Tilly Schilling didn't care about impressive. She cared about keeping pilots alive. Without official approval, she started building prototypes. Not at the RAE, at home, in her own workshop, at night, using her own equipment, on her own time. She was a senior engineer at a government research facility, designing unauthorized modifications to frontline military equipment in her garage after hours. In most organizations, this would be career suicide. But Schilling knew something the bureaucrats didn't. Word was spreading. The pilots had heard about her work. They'd heard that someone at the RAE had a fix for the negative G problem. A simple fix. A fix that could be installed immediately. And the pilots were desperate. They pressured their commanders. Their commanders pressured the Air Ministry. The Air Ministry started asking uncomfortable questions. Finally, someone at the very top took notice. Air Chief Marshal Hugh Dowding. If you know anything about the Battle of Britain, you know that name. Dowding was the commander of RAF Fighter Command, the man responsible for the defence of Britain against the Luftwaffe. He was stubborn. He was brilliant. And he was absolutely focused on one thing: keeping his pilots alive so they could keep fighting. When Dowding heard about Schilling's work, he made a decision. His exact words, according to multiple accounts, were something like this: "We have nothing to lose and plenty to gain. Let her get on with it." With Dowding's backing, everything changed. Schilling was given a Merlin engine. She set it up in the Farnborough workshop, mounted in a special cradle that could be tilted to any angle. She could simulate straight flight, climbing, diving, inverted flight, anything. Then she ran the engine, over and over, with her restrictor, without it, with different sized holes, testing, measuring, refining. The tests proved what she already knew. With the restrictor in place, the engine could handle brief negative G maneuvers without cutting out. It wasn't a perfect solution. You still couldn't fly inverted for extended periods. But it solved the combat problem. A quick dive to follow an enemy. A sudden pushover to evade fire. The maneuvers that happened in actual dogfights. The restrictor worked. But proving it worked was only half the battle. Now she had to get it installed in every Spitfire and Hurricane in RAF Fighter Command. If you want to see how Tilly Schilling got her brass washer installed in every fighter in the RAF, please hit that like button. It helps us share more forgotten stories from World War II. Subscribe if you haven't already. Back to Tilly. The installation campaign began in early 1941. Schilling assembled a small team, engineers who believed in what she was doing, mechanics who could do the work quickly and correctly. And then Tilly Schilling did something that surprised everyone. She didn't send her team out alone. She went with them, on her Norton motorcycle, the same type of bike she'd raced at Brooklands, the same type of bike she'd supercharged to 106 miles per hour. In the winter of 1941, Beatrice Shilling rode her motorcycle from RAF base to RAF base across Britain, in the cold, in the rain, in the blackout. At each base, she oversaw the installation of her restrictors. She answered questions. She trained mechanics. She made sure the work was done right. She didn't have to do this. She was a senior engineer. She could have stayed at Farnborough and supervised from her office. But that wasn't Tilly Schilling's way. The installations went quickly. The restrictor was simple. It could be welded into the fuel line without removing the engine from the aircraft. A skilled mechanic could do it in an hour. And the pilots were eager. Desperate even. Word had spread through the squadrons. The brass washer fix. Miss Schilling's solution. By March 1941, every fighter in RAF Fighter Command had been fitted with the RAE restrictor. The reaction from pilots was immediate and overwhelming. Reports came back from the squadrons. The cutouts were gone. Pilots could push their noses down without their engines dying. They could pursue Bf-109s through maneuvers they'd never been able to follow before. The playing field wasn't quite level. British pilots still couldn't fly inverted for long periods, but in the quick, violent exchanges of actual combat, the restrictor made all the difference. And then the pilots gave the device a name. The official designation was the RAE restrictor. But pilots didn't call it that. They called it Miss Schilling's orifice. The name was obviously suggestive. The rough and ready air crews of RAF Fighter Command weren't known for their delicacy. But there was affection in it too. Gratitude. Miss Schilling's orifice. The brass washer with a hole in it that saved their lives. The nickname was apparently coined by Sir Stanley Hooker, the brilliant engineer who led supercharger development at Rolls-Royce. Even the Rolls-Royce engineers, the ones whose proper solution was still years away, acknowledged what Schilling had accomplished. There were other variations. Miss Tilly's diaphragm, the Tilly orifice, all playing on the same joke. Schilling apparently didn't mind, or if she did, she never said so publicly. She had other things to focus on. The restrictor was a stopgap, she knew that. It solved the immediate combat problem, but it wasn't a permanent solution. The RAF still needed a pressure carburettor that would work properly under all conditions. Schilling went back to work. She designed what she called the RAE Hobson pressure carburettor. It was a more sophisticated solution than the restrictor, a complete replacement for the SU carburettor that would eliminate the negative G problem entirely. The RAE Hobson was never produced. The war moved faster than the bureaucracy. By 1943, other pressure carburettors, the Bendix-Stromberg designs from America, were being installed in new aircraft. But by then, Miss Schilling's orifice had done its job. For 2 critical years, 1941 and 1942, the brass washer kept Spitfires and Hurricanes fighting. It remained installed in all pre-1943 aircraft that still had their original Merlin engines. A simple brass disc with a hole in it, designed by a woman who'd been banned from entering the engineering building, tested in her home workshop at night. One of the most important modifications of the entire air war. How many lives did Miss Schilling's orifice save? There's no way to know exactly. The RAF didn't keep statistics on pilots who would have died if their engines had cut out during a dive, but we can make some estimates. During 1941 and 1942, RAF Fighter Command flew thousands of sorties, combat missions against the Luftwaffe, sweeps over occupied France, defense against German bombers. Before the restrictor, engine cutouts during negative G maneuvers were common. After the restrictor, they were rare. Even if we assume conservatively that the restrictor prevented 1 fatal engine failure per week, and the actual number was probably much higher, that's over 100 pilots saved in 2 years. 100 lives. Because a woman who'd been told she didn't belong in engineering refused to accept it can't be done. In 1949, Beatrice Shilling was awarded the Order of the British Empire for Services to Aviation. The citation didn't mention the brass washer. It didn't mention the midnight work in her home workshop. It didn't mention the motorcycle tour of RAF bases in the winter of '41. It didn't mention Miss Schilling's orifice. Just services to aviation. Tilly Schilling probably didn't care. She'd never been interested in credit. She'd been interested in solving problems. And she wasn't done solving them. Beatrice Shilling remained at the Royal Aircraft Establishment until her retirement in 1969. In those 33 years, she worked on projects that sound like science fiction. The Blue Streak missile, Britain's attempt to build a nuclear deterrent in the late 1950s. Supersonic aircraft and rocket propulsion. Research into how wet runways affect aircraft braking. Work that made commercial aviation safer for millions of passengers. And in one of the strangest projects of her career, she helped design a bobsled for the Royal Air Force's Olympic team for the 1968 Grenoble Winter Olympics. A brass washer, a ballistic missile, a bobsled. That was Tilly Shilling's range. She never stopped racing either. After the war, she switched from motorcycles to cars. She and her husband George Naylor, himself an RAF bomber pilot and engineer, modified a 1934 Lagonda Rapier and later an Austin Healey Sebring Sprite. They raced together at Goodwood Circuit for years. Tilly was still racing into her 60s. The same woman who'd lapped Brooklands at 106 miles per hour in 1934 was still finding ways to go fast 4 decades later. In 1956, Schilling joined the Institution of Mechanical Engineers under her married name of Naylor. In her application, she cited her contribution to the RAE restrictor. The institution probably had no idea what she was talking about. In 1969, she received an honorary doctorate from the University of Surrey. Beatrice Tilly Shilling died in 1990 at the age of 81. There's a pub in Farnborough named after her now. The sign shows her on a motorcycle. It's not a statue. It's not a monument. It's a pub sign. For a woman who saved the RAF with a 50-cent washer, it somehow seems appropriate. Schilling's story is part of a larger pattern. During the Second World War, women worked in every industry, solved every kind of problem, contributed to victory in ways that were often invisible and almost always unrecognized. 2 decades before Katherine Johnson, Mary Jackson and Dorothy Vaughan broke through racial and gender barriers at NASA, the women celebrated in the movie Hidden Figures, Beatrice Shilling was already there, fixing things that men said couldn't be fixed, doing work that women weren't supposed to do, changing history with a brass disc and a precisely calculated hole. The next time you see a Spitfire, in a museum, in a movie, flying at an air show, remember Tilly Shilling. Remember the motorcycle racer who became an engineer, the engineer who was banned from the building, the woman who tested her invention at night in her home workshop. Remember Miss Shilling's orifice. If you found this story fascinating, please hit that subscribe button. We share forgotten stories from World War II every week. And if there's another hidden figure from the war you'd like us to cover, let us know in the comments. Until next time.